What is going on, everybody? Got another video here for you. We've got a exponential logarithmic application problem. So let's go ahead and take a look at it and see what we got here. It says on a college campus, 5,000 students. Of 5,000 students, one student returns from vacation with a contagious and long-lasting flu virus. The spread of the virus is modeled by, so that's y equals 5,000 over 1 plus 4,999 times e raised to the negative 0.8t, where t is positive. So y represents the total number of students infected after t days. So if we want to know how many students are infected after so many days, so however many days, that's going to go in for t, and then the answer you get, that's going to say, okay, this many students are infected. The college will cancel classes when 40% or more of the students are infected. So for part A, how many students are infected after 5 days? And part B, how many days will the college, after how many days will the college cancel classes? So that'd be good to know when we want to cancel the classes. Get a kind of an estimate. All right, so let's take a look at part A. So part A, so for part A, it says, how many students are infected after 5 days. So 5 days, that represents t. So all we're going to do is take 5 and plug it into that function for t. So we've got t is equal to 5. So that's going to give us y is equal to 5,000 over 1 plus 4,999 times e raised to the negative 0.8 times 5. And then you will need to punch that into your calculator, and it's going to be about 54. So it comes out to 54.019085542. So 54, we don't do a percentage of a student or part of a student. All right, so now let's look at part B. This is going to be the one that's a little more tricky. So we got part B here. So let's just go ahead and write our function here. So y equals 5,000. I'm just writing it here so we can see it. All right, so there's our function. All right, so what they're asking, after how many days will the college cancel classes? All right, so we're looking for t, the number of days. Now, how do we know when they're going to cancel classes? Well, the college will cancel classes when 40% or more are infected. All right, so let's look at this. There are 5,000 students total, and when 40% of them are infected, that's when it's gonna that's when they're gonna cancel classes. So that's gonna be when 40% of 5,000. So 40%, that's 0.4 or 0.40, it doesn't matter how you write it, times 5,000 is equal to 2,000. So when 2,000 students are infected, that's when they're going to cancel classes. All right, so when 2,000 students, what is 2,000? Y is the total number of students infected. So when Y students are infected, in this case, 2,000 are infected, that's going to equal 5,000 over 1 plus 4,999 e to the negative 0.8t. All right. So now all we have to do is solve this thing for t. So what I'm wanting to do is I want to get this right here by itself. That's what I got to solve for. E to the negative 0.8t. That's what we're looking for. All right, so we can look at this as being over 1, and we can cross multiply. So that's going to give me 2,000 times 1 plus 4999 e to the negative 0.8t is equal to 5,000. All right. All right, so there's a couple ways we could do this. I think the easiest way is probably, let's just go ahead and divide everything by 2,000. I think that'll be the easiest thing to do. So we're going to get 1 plus 4,999 e to the negative 0.8t is equal to 5 halves. So we could write 5 halves. Let's write 2.5. Let's just write it as a decimal. That'll work. That'll be just fine. All right, and so now we're going to subtract 1 to both sides. So that's going to give us 4,999 e to the negative 0.8t is equal to 1.5. And then we'll need to divide everything by 4,999. And that is going to leave us with e to the negative 0.8t equals, and that's going to be 1.5 over 4,999. We'll just leave it as a fraction. That'll be fine. All right, so we need to get t by itself. Okay, so look at this. This is just an exponential equation that we need to solve. So think back to what you learned. Okay, I'm just going to come off to the side and just kind of remind you of something. So do you remember when you had something like 2 to the x equals 5? Something, just say something like that. Or do you remember when you had like 2 to the x equals 4? Or instead of 4, let's just do 8. That'll be fine. Remember when you solved this, you would write this as 2 to the x equals 2 cubed. You would get the basis the same, and then you knew the exponents had to be equal. But what happened when you couldn't get the basis the same? What did you do? You took the natural log of both sides, right? Took the natural log of both sides. So that's what we're going to do here. We're going to take the natural log of both sides. And so that's going to give us the natural log of e to the negative 0.8t equals the natural log of 1.5 over 4,999. All right, so the left-hand side is negative 0.8t is equal to the natural log of 1.5 over 4,999. All right. So wait a minute. What just happened? How did we get this? What happened to the ln and the e? Okay. So let's go over this just real quick, because this is very important. This is one of the things students tend to not grasp. Okay. So let's say that we have the log with base b of b raised to the x. Okay? So if the base of the log and the base of the exponent are the same, see how the base of the exponent and the base of the log are the same? Your answer is just your exponent. Okay? So let's look and see what we have here. Well, one other thing we've got to remember is that the log of x with base e is equal to the natural log of x. So what we do, instead of writing log base e, we abbreviate it with ln, natural log. That's all it is. So what do we have here? We have the natural log of e to the negative 0.8t. Okay, that's what we've got. That's this left-hand side. Well, remember, ln is log base e. So that can be written as log base e of e to the negative 0.8t. And since the base of the log are the same and the base of the exponent are the same, we come back up here. That is just equal to your exponent. Okay, now we don't normally write this out like this. You just leave it as ln. You've just got to know and picture in your head that ln, that has that base e there, and that's what happened over here when I did the left hand side. All right, and so now we can divide everything by negative 0.8, or we could multiply by negative 1 over 0.8 to cancel this out. See, it'll cancel out here and leave us with just t, and that's equal to negative 1 over 0.8 times natural log of 1.5 over 4,999. And then, of course, you would plug that into your calculator, and you're going to get about 10.1. So we would say after about 10 days, classes will be canceled. Okay. And there you have it. So, it's a pretty good problem. Not a lot involved. Part B was a little harder than Part A, but we got it. Alright, so I hope you enjoyed that video. Hope it helped out. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.